Welcome back if you've had videos before, or welcome if this is the first time watching one of my videos. This video here we're going to tackle the quotient rule. Specifically we're going to tackle what the quotient rule is and where it comes from. Or you might say we were going to derive the quotient rule. As we do with many rules involving derivatives, we begin by creating a second function, a new function, that is a quotient of two functions. Of course, being f of x over g of x. Here we need to be sure that g is not 0. G of x can't be 0. Otherwise it's undefined. So we begin with our limit definition. K prime of x would be the limit as h goes to 0 of k of x plus h, which would be f of x plus h over g of x plus h, minus f of x over g of x, all that over h. And so as we begin to approach this, we say, well, this is a complex fraction. So anytime we have a complex fraction, step one is let's get rid of the complex fraction. So we multiply both top and bottom by the common denominator. And we're okay doing this because k of x is not defined when g is 0, so g of x can't be 0, and we can always make h small enough so that that also wouldn't be, g of x plus h wouldn't be 0 either. So we multiply through. And then it's just now a matter of simplifying. And so we've done so now. At this point, we would like to involve the limit, somehow find a way to involve the derivatives of f and the derivatives of g. If you remember, the derivative of f would be the limit as h goes to 0 of f of x plus h minus f of x all over h. And as we look here, we see we have f of x plus h times g of x minus f of x times g of x plus h. And we say, oh darn, if only that had been a g of x there with the f, then we would have been able to factor the g of x out and have f of x plus h minus f of x. And so since that's what we need, we give that to ourselves. So I subtract off an f of x g of x. That way I can now factor out the g of x and have what I need. And likewise, since I subtracted that, I need to add that to both sides. And that'll all be over h. Okay, at this point in time, oh, forgot the other stuff. At this point in time, we're now ready to start doing some factoring and hopefully have some things start to turn out. So at this point, notice here that I have this quantity. This quantity I can factor and g of x out, right? And then I would have g of x times f of x plus h minus f of x. That would all be over h. So I would actually be able to talk about the derivative of f. And then if you look at the second part here, if you factor out an f of x, you'll have g of x minus g of x plus h. So that's backwards. But if I factor out a negative f of x, that will give me g of x plus h minus g of x on the inside. And so that's exactly what we're going to proceed to do now. So we begin doing exactly what we've just discussed, factoring out the g of x out of that quantity, factor out the negative f of x out of the other quantity. and then it'll all be over h g of x plus h. Okay. If you want to challenge yourself, you want to pause this to think, how would you go from here? Okay, so we continue to simplify. Now, what I'm going to do is break this up a little bit. I have two big fractions I can break apart. I'm going to have my g of x times 1 over that denominator, well, part of it anyway. I'm saving the h for something else. And then f of x plus h minus f of x over h. Oops. Sorry about that, I hit the wrong button. So f of x plus h minus f of x over h, so we have the derivative there. And now, in the second part, we factor out the f of x. And again, the g of x, 1 over g of x plus h. And then we're left with only g of x plus h minus g of x. Over h. And you may want to pause and take a moment to see that that is in fact equal to the stuff that we had above and where everything came from. And continuing through now, we can take the limit. The limit of g of x is g of x. Now remember that g of x can't be 0, so as h goes to 0, 1 over g of x plus h is g of x. Yes, you can cancel g of x out, but we really don't want to. And then the limit of the f of x plus h minus f of x over h, that's just f prime. And we continue to the second part. Limit of f of x as h goes to 0 is f of x. The other stuff is going to be 1 over g of x. And the limit of g of x plus h minus g of x over h is g prime. Now we're almost there. We just need to clean up our problem a little bit. In the top we'd have g of x times f prime, and then minus f of x times g prime. And then those two fractions of g of x, I'm going to put that down in the bottom as my common denominator. And there we have it. That is the quotient rule. We take the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, and it all gets divided by the bottom function squared. Okay, so hopefully this derivation helps you out in understanding where the quotient rule comes from.